Assalamualaikum warahmatullahi wabarakatuh. My name is Ahmad Mustaqim, and I will present how to construct the simulation for MATLAB. Okay, first, when open the MATLAB, create a new Simulink model and choose blank model. After that, to pick the component, simply click library browser, and here we can pick or find our component like voltage measurement and add block to the model. After that, after add to the model, automatically the component will be in this workplace. So after that, simply rearrange the component and change all the value that based on the question, like period, pulse, and phase delay. Change it based on the question, and with RC with 0.01 and capacitance with 4.0 e power of -6, and for 3 series branch, simply change the branch type to R and resistance to 10, and change the power GUI to discrete, and sample time is 5e-8. So okay, this is for setup for 120°. So after that, I copy all these component, make it for 2 copies, and for this circuit, this is for 180°. The difference between this circuit and this circuit, for 180°, I change the pulse width to 33.33, and make sure all the go to and also from must same number. Okay, that's all from me. Thank you.
Assalamualaikum warahmatullahi wabarakatuh. My name is Aiman Fikrie bin Shafie. My matric number is DE190143. As for today, I'm going to present about the lab activity number 2, which is we need to execute the constructed circuit in the activity 1, which is the VSI voltage source inverter block model that we created in the Simulink. And then we need to find out the switching signal, phase to neutral, and also line to line voltage waveform. So as we can see here, this is the block model of the voltage source inverter, and then this is the 3 parameter that we need to measure, which is the switching signal, line voltage, and phase voltage. So for the first step, we need to run the system, and I run it earlier, and then we will obtain our output waveform here for the switching signal. For the first part switching signal, it will measure about how the MOSFET condition when the circuit is running. So there will be 6 segments, segment 1, 2, 3, 4, 5, and 6, which is indicated to the 6 MOSFET that we have in the block model. So as for the step 1 in this output waveform is a discrete output waveform, which is at the 1 condition the MOSFET will be on, at the 0 condition the MOSFET will be off. So that we need to determine which MOSFET will be in a on condition at certain step. So as we can see here, we can divide this discrete graph to 6 parts, which is as we know that this is for the 180° conduction mode. So for the step 1, we assume we prefer to the on condition. So for the step 1, which is here, 1 MOSFET number 1, MOSFET number 5, and also MOSFET number 6 will be in on condition. For step number 2, MOSFET number 1, MOSFET number 2, and MOSFET number 6. So as for this output waveform, only 3 MOSFET will be on at at each step, and then the process will be the same until it reach for the 6th step, and then after that the output waveform will repeat the same process until it reach the stoppage time. So that's it for the switching signal. And then for the next part, which is the phase voltage. So here is the phase voltage. Theoretically, phase voltage can be calculated by using this formula. VAN equal to VCN, V divided by 3. So VBN equal to negative 2 volt, 2 V minus 3. V is indicated as the voltage source. So as we can see here, the output waveform here is the VAN. The first one, the VAN. The second one is VBN, and the third one is VCN. Okay, in order to find out the value, for the previous calculated theoretical value, VAN and VCN we get 33.33 volt. But VBN we get negative 66.67 volt. That is in theoretically. For the simulation part, we need to find the value of the three parameter that we calculated earlier, which is we need to use the peak finder here in order to find the peak value of the output waveform, and the cursor measurement to find the other two value. So the process of reading this graph is same as the switching signal, where we can divide it into 3 steps. So this is for one complete cycle. It starts from 0.0253 until 0.0254. That one complete cycle. So for the step 1, which is here is 33 VAN equal to 33.01, which is here. The VBN is negative 66.01, which is here. It negative because it in the negative region. And the next VCN is equal to 33.01. The value is slightly different because due to the internal resistance in the circuit. So same goes to the next step. Only the difference is the positive and negative sign, because this is a continuously operate. And then after it is the complete one cycle, it will repeat the same process until it reach the stoppage time. Okay, last but not least, which is the line voltage here. Line voltage. Okay, as we can see here, line voltage. Theoretically, we can get the line voltage value by subtracting the phase voltage. Therefore, the phase voltage value is important. As we can see here, this is VAB, VBC, and VCA. So as the value of V theoretically we get the positive value, VBC will get negative value, and VCA will get 0. So from the graph, where we can read as same as the previous two signal, which is 6 step. So for the first step, which is here, 100, which is the positive value, negative 100 is negative value, and 0. So therefore, it can be concluded that it matches the theoretical value. And then for the next step, is the same process where the only different positive and negative sign will be different. Therefore, after it reaches the step 6, it will repeat the same process until it reach the stoppage time. I think that's all from my part. Thank you.
Assalamualaikum warahmatullahi wabarakatuh. My name is Abdul Azim bin Muhammad Fauzi, and my metric card number is DE190145. So today I will explain for lab activity number 3, which is to modify the pulse generator to generate the PWF waveform with the condition based on 120-degree conduction mode, and to find a few parameters needed for this lab. So as we can see here, the top one is the 180-degree conduction mode, and the second one is the 120-degree conduction mode. So the circuit in the MATLAB Simulink is approximately the same, but there will be a slightly different value in the pulse generator. So I will show in detail later. Okay, next I will explain in detail for what is the differences. So we will focus on the 120-degree conduction mode circuit here. I will zoom it first. Okay. Now we got the full circuit, Simulink circuit. So the difference between these two circuit is that the angle, which is from 180 degree to 120 degree, so it affects the pulse generator here. For the switching signal, there are 6 pulse generators. So for 180 degree, the pulse width is in percentage. So 180 degree is the 50% of 360. So same goes to 120 degree. When we change it to percentage, it becomes 33.33%. So there goes the pulse generator from S7 switch 7 to switch 12. The pulse width is 33.33%. That is the one of the differences between 180 degree to 120 degree conduction mode. So and then the pulse, the phase delay is same as the 180 degree. So the first one is 0, and then the second one is 1.666 exponent negative 5, and then the third one is 3.333 exponent negative 5. The fourth one is 0.0005. The fifth one is 6.666 exponent negative 5, and the last one is 8.323 exponent negative 5. So here goes for the pulse generator. And then there are a few parameters needed in this lab, so which is the switching signal, the line voltage, and phase voltage. So I will show you on how to determine the waveform of this parameter. Okay, next for the switching signal, as we can see here, this is the scope for the switching signal, and then what we have to do is we just have to run the circuit and then stop. Then we just have to press the scope and to find the output. So I already run the simulation. So here is the switching signal. So as we know that one cycle is equal to 360 degree, so there will be a 6 division of 360 degrees. So it consists of, so one step is equal to 60 degree. So here has 6 steps. So here is the first step, second step, third step, fourth step, fifth step, and the last one is the 6th step. And then the pattern goes on and on until the stoppage time. So for the first step is from 0 degree to 60 degree. So as we can see, we have to see which switch is in a closed condition. So which means when it's closed, the switch signal is at 1. So here's the switching signal at step 1 is, which is in on condition, is at S7 and S12, and then goes to S7 and S8. The next one is S8 and S9. Next is S9 and S10. There goes S10 and S11. The last one is S11 and S12. And then, as I said earlier, that the pattern goes on and on until the stoppage time. For the simulation, the stoppage time is at 0.04 second. So to prove this simulation, I will show the theory, which is as we can see here at the lab sheet. So for this here, this firing sequence for 120 degree conduction mode. So for step 1 is the MOSFET in closed condition is 6-1. As we can see here, 6-1, and then 1-2, 2-3, 3-4, 4-5, and 5-6. So this means that this output simulation waveform is the same as theory, which means that this simulation is right. And then we goes on to the next parameter. Okay, for the next parameter, we go to the phase voltage here, which is VAN, VBN, and VCN. So I already run it earlier. And then here is the phase voltage. Okay, as we can see here, the output voltage here is at 50 volt. This is negative 50 volt and 0. I'm sorry, not 50 volt. Is from the peak finder, we can see that the voltage is 4.95, which equal to 49.5 volt. Same goes here, negative 49.5 volt, and then this is 0 volt. So to find this voltage here, we can use the formula in the lab sheet. Here is stated that the phase voltage are equal to line voltage. Therefore, we can see that the formula is for VAN here, for VAN and VBN, the formula is equal to V voltage over 2, which is V source over 2, and for VBN is negative Vs over 2, while VCN is equal to 0. So this is for the first cycle, because as we can see here, at the first cycle, which is from 0 to 60 degree condition, the only MOSFET that on or the switch is closed are here, which is S1 and S6. So there will be a voltage or current here goes to the three-phase series RLC branch here, and then there will be also a current here at the B terminal, and but there are no switch close here, so there will be no current at the C terminal. So the C terminal will be will be open, so the voltage is 0, while the terminal A and B, for just like I said earlier, the formula is Vs over 2. For BBN is equal to negative Vs over 2. So as we can see at the simulation, so we know that Vs equal to 100, and then for the VAN, the formula is Vs over 2, so it equals to 50. And then for the VBN is equal to negative Vs over 2, so it will get negative 50, while VCN is equal to 0. As we use the peak finder, the value is equal to 4.95 or equal to 49.5 volt. So this is because of the internal resistance. So that's all for phase voltage. And then for the then for the line voltage here, which is here, and then what we have to do, we just have to run and stop and press the scope here, and I already run the simulation. So here's the line voltage. So what we got here is at 100 volt, which is VAB, VBC, and VCA. For VAB is equal to 100 volt, VBC is negative 50, while VCA is equal to negative 50. So as we get the output, we have to see the theory first. So for the calculation, it's stated that VAB is equal to V source, while VBC and VCA is equal to negative V source over 2. So this has proved the simulation, which means that as we know that VAB or V source is equal to 100, so here goes the 100 volt, and then VBC and VCA is equal to negative V source over 2, which means equal to negative 50, so here goes the VBC and VCA negative 50. So this simulation is already proved the calculation. So therefore, as I mentioned earlier, that this is the calculation for the first cycle, which is from 0 to 60 degree. So as we know that there will be 0 to 360 degree, which consists of 6 steps. So every step I need to calculate, and I already show you the first step. For the second to 6th step, we just have to apply the same formula but referring to the equivalent circuit for each step, because there will be different type of switches closed in every step. So that's all from me. Thank you.